Butt hurt.
Butter?
I had
Butter?
butt hurt.
You're so butthurt about this. You've never heard that.
No math teacher has ever heard this. Mr. Warnock.
Okay, are you sure it's a word?
Yeah.
It
is.
is.
Butter.
It's
Yeah.
like
Can I
like,
call Mr. Kane? Phone
it's like a
friend?
Yes, you
chaos
can.
or loser thing.
Oh, I should ask.
Call
I'm not kidding you. Me and Mr. Warnock had a 30-minute scream off in study hall today because he thinks that we're stupid.
Butthurt is definitely a
Well,
word.
I'm
It's
sure he
in-
doesn't think that.
According to Merriam-Webster, it's a word.
Oh,
Which
so it's in like the Webster dictionary.
and it's in the Oxford one too.
Ooh, we have one of those.
Well, apparently I'm done.
So it's an old word, not a new word.
No, I
No.
feel like it's a pretty new word. It's the same term as like sore loser. Like when someone gets all pouty when they don't win, they're being very butthurt about it.
Okay.
That just sounds
I
like
don't
a word that I
understand. How
heard
did no one know what that meant?
People use it all the time, I feel like.
Yeah.
But
Right?
you
Yeah.
don't.
So I need to start using it.
It's like, if you say something to your, this is the point there, like, you say something to your daughter, and they get mad when you say, don't say blunder about it.
Okay, I'll
And he'll look at me like,
She definitely knows what it means, so you can.
It's like the moment. Yeah.
okay.
Stay
You just
away.
told me my dog was last saying, what the? She's like, what the?
Yeah, I
You
really-
can't walk around and say that because the next word is about it.
Yeah, I really have that first. It never ends. It never ends well.
What are you doing? You got a long name.
So she gets charged a quarter every time she says it.
You
We're
have
up to
a
$1.25.
Me and my
No,
friend
I
every time we do
Alright,
the
so if you can look at page 36, I think this is
35.
35. Okay, I'm on page 35. That's close.
Good enough is what I'm saying.
Good enough, right? The directions for 3, 4, and 5 want you to find the specific solutions, so that means the actual angle values. You don't have to use that plus 2 pi n in radians or in terms of pi, which all the answers work out nice. So you don't have to use a calculator, everything's going to be in terms of pi. How would you start number 3? So when you look at it, and like you have your identity sheet, Brandon, how would you start number 3?
I changed cosine 2x to 2 cosine squared x minus 1.
And why did you use that form?
Because we have a cosine in the problem and I don't want to really add a sine into the problem.
Okay. So he said he used 2 cosine squared x minus 1. And his reasoning was, there's already 2 cosines in the problem, so maybe it'll benefit you when you change it to just keep a cosine in the problem instead of adding an extra function. And that's a good thing to think about. Like when you change something, you want to try and not add extra functions into the problem when at all possible. But if you did use cosine squared minus sine squared, you can use the identity, Pythagorean identity, and eventually get it out. So it's not like you went totally wrong. So this is the double angle formula for cosine. It becomes 2 cosine squared x minus 1. And then the other part, excluding the 5, let's just look at this part here. So it says cosine x plus pi. What could you do with that? Chelsea?
Make it cosine x times cosine pi minus sine of x times tan.
So that is called the sum formula. So this is the sum formula, the sum of 2 angles. It's cosine in the front, so it's the sum formula for cosine. But you have angle A and angle B. So the formula says take the cosine of the first angle, the cosine of the second angle. And then she said minus the sine of the first angle, sine of the second angle. So there's no way to get around the sine in that one, but there is something nice that'll happen. So you have to get the sine in there, but it'll work out nicely. So essentially you took a little equation, because it looks pretty little right now, and you actually blew it up and expanded it, but it's going to go back down and shrink. Inside here, we have a cosine with a pi and a sine with a pi. If you have a function with an angle that you know, then evaluate it. So what is the cosine of pi? Think on the unit circle, pi is on this side. What is the cosine of pi, Chelsea?
-1.
Yeah, so the cosine of pi, I'm going to take that out and make it a -1. Because you can change it. It's a number. It's related to the unit circle. So really, this says we have negative cosine with the 5 still in the front. This -1 times cosine is negative cosine. Chelsea, looking at the second one, we have the sine of pi. So over here's pi. the sine of pi is 0. And Chelsea, when you take negative sine times 0, you get 0. So technically, there's a plus 0 back here because we took out the sine of pi, replaced it with 0. But 0 times anything is really just 0. And then it's equal to negative 3. There's still what Brandon gave us, 2 cosine squared x minus 1, and then the plus 5. So Brandon's initial thought was to keep cosine in the problem and not switch it to something with a sign in it, and that was a great thought because now all we have left is cosine and numbers. So if we rearrange this so that we have a 2 cosine squared, 5 times negative cosine is negative 5 cosine. 5 times 0 is nothing, so the only part we have there is negative 5 cosine. And then adding the 3 with the numerical value of that minus 1 gives us a plus 2, and then it's equal to 0. The majority of these problems, we want to get equal to 0 because most of them are going to be solved by factoring, some type of factoring. Questions? So the first step involved 2 different trigonometric formulas, the double angle formula, the sum formula. And then after you evaluated those 2 parts in the sum formula, now at this point we have to do algebra before we can use trig again. So algebraically, if you want to think about this as 2x squared minus 5x plus 2. If you don't like looking at cosine. Michael, how would you solve something like that?
Leave the negative 5x out minus 4x and a minus x.
And then,
And then I took out a 2x on the left part, and then just a negative 1 on the right.
so factoring it algebraically using that AC grouping process, and then throwing the cosine back in after you get it factored. So this is 2x and minus 1, or 2 cosine x minus 1. And then we have the x minus 2, well, x is now cosine minus 2, and we got it equal to 0, so we can set it equal to 0 plus 0. So all the algebra is done. So we did trig with formulas, a whole bunch of algebra. Now the last step is to go back and look at trig. So solving this, the cosine is 1/2, and the cosine is 2. So the last part is to look on the unit circle. Ask yourself, when is cosine 1/2? And it has to be the first and the 4th quadrant, because that's where cosine is positive. So we need 2 angles where cosine is positive 1/2. Michael, what would they be?
5/3 and 5/3.
Yeah. So after you do all the trig, the last step is to go to the unit circle. Look on the unit circle and find out whatever value you're looking at, cosine, sine, tangent, when does it have that specific value on the unit circle? The other part says the cosine is 2. When is the cosine 2 on the unit circle? 8? Never. Because the values for cosine and sine have to go between -1 and 1. So that part of the function is undefined. There is no solution. So no answer from the cosine being 2, because if it's beyond 1, below -1, you won't have a solution. So 2 angle answers, and that's from the first part, that cosine is 1/2. Questions? I think some of you got that. Brendan?
Are we ever gonna get an answer where, it's not gonna be like cosine x equals 1/2, it's gonna be a different number, and we're gonna have to do what we did yesterday to find that? Like a problem that involves everything, like.
I'm not sure I understand. What do you mean, like what we did yesterday?
Never mind.
So like an angle that isn't on the unit circle?
Yeah, like you have where like we have cosine x minus 2, where it wouldn't just be like that, it would be something that's not on the unit circle.
If that were the case, then you'd just use like the inverse cosine, the inverse sine, the inverse. no, you wouldn't have to then go use another formula to try and find the answer. That is. Other questions on number 4? We can go to number 4 as well. Doesn't matter to me. I'm free all day. Till 2 o'clock. Yeah. All right. So let's look at number 4. I'm just going to do it on a separate page. So for tangent, and then I had it memorized. Sine 2x. This one's equal to 0. Again, solve. So we want to try and solve for x. Kate, where do you think you'd start?
I'm not sure this is right, but I first made tangent sine over cosine.
Yeah, that's good. Because again, like you have a sine over here, so you might as well make tangent be in one of those forms or one of those functions. So sine over cosine. The 4 just stays on the top with the sine. What else, Kate?
And then, see, I think this is where I'm wrong. No, wait, no. And then I made the sine 2x to sine x times cosine.
That sounds good. That's a good start. So the first one is an identity. That's the quotient identity for tangent. The second one is the double angle formula for sine. So you have an identity that we used and a formula that we used. So again, like you use trig. After you're done with the trig part, then you're back to algebra. So Brandon, do you have an idea?
You can factor out 2.
So we could factor out a 2. Let's just hold off with that because then that gets parentheses in the problem. I mean, that's not wrong at all, Brandon. It just sets like extra parentheses that we don't need quite yet. Sabrina?
I got both the common denominator.
So if this one has a cosine, this one also needs a cosine. So Sabrina, the top becomes,
And cosine squared x.
yeah. And now it's all over cosine because we had that common denominator. So again, Brandon, not wrong. I just like to hold off on the parentheses until I've got everything else done. That's just me being particular, I guess. I'm stuck in my ways. Alright, so now we have one fraction. Got the numerator combined on the top. What do you do with that dividing cosine?
Since the rest of them are sine, I made the cosine a 1 minus sine squared x
Okay.
using the sine squared plus cosine squared equals 1 formula.
So Sabrina said, since it has all this sine on the top, she changed this one back here to say 1 minus sine squared, which is one way to solve the problem. Remember, there are always many ways to solve the problem. So that's one option that you could do. Is there something else that you could do? Not wrong. So I'm going to just hold off on her thought for a couple seconds here. How can you get this so that it's no longer a fraction? Like it's sitting as a fraction right now. We're dividing by cosine. How could I get it out of that fractional form? You could multiply by secant, but then that adds an extra function. Sabrina?
You could factor out the fraction and put it on the outside.
So if you're dividing, whatever you're dividing by, to get rid of that part that you're dividing by, I never have any markers over here. Mr. Cummings always puts them. It must be. He works, I guess, just on that side. Well, he wrote something over here. So if we have 3x plus 2 divided by 2 equals 0, what would you do with that divided by 2 part? Brandon? Yeah, multiply it to the other side because we want to get rid of it. We don't want it to be in a fraction. Dividing by 2 is the same thing as, or getting rid of it is multiplying by 2 because then they cancel. And then we have 3x plus 2 equals 0. So, Virginia, I'm sorry.
So, I mean, you could just go away and
Yeah, it just goes away because if you multiply by cosine, Like dividing by 2 is the same thing, or you can get rid of it by multiplying by 2. They undo each other. So if I'm dividing by cosine and I want to get rid of it, I would multiply both sides by cosine so that you're no longer dividing. Well, 0 times cosine is still 0. But if there was a 5 over there, then it would be 5 times cosine. But to get it to the other side, to get it out of fractional form, whatever's in the denominator, multiply by it to get it to that other side. So we have 4 sine plus 2 sine times cosine squared. And I told Sabrina to just hold on to her thought. So you could change cosine squared to 1 minus sine squared. That would be one thing, and if that's what you see, that's fine. So it's really about what you see in the problem. Virginia, do you see something else in the problem?
Well, I just have a question.
Sure.
Because, like, I don't remember when this happened, but I heard you said once that you don't want to divide because it takes out answers. When does that happen and why can't we do it now?
That would be if we had sine equals to 2 sine squared, and you would say, I want to divide by sine. Because then, like, it really is, you're dividing it out of the problem and going away.
Okay.
But there, because you're multiplying by 0, you're not really dividing it out. There's just a 0 on the other side, so 0 times anything has to go. Brandon?
Could we factor out 2 sine x?
Yeah, you could factor out a 2 sine x. So going back to my question, so Sabrina said she would change this piece here to be 1 minus sine squared, which is not wrong at all. That's an option. But the other option, if they both have something in common, you can still factor it. So they don't always have to be the same terms. Sometimes you could have different terms, but that one term that's different can be factored out as well. So we could pull out a 2 sine x. So again, Virginia, we're not dividing that out, like in getting rid of it. We're keeping it in the problem, we're just like separating it. So this becomes 2 plus cosine squared. So factoring really is a way of dividing it out, but keeping it in the problem instead of literally dividing it out. Questions? So the last step, we've done the algebra. Again, there were a couple of different steps we could have done algebraically. I was just trying to show you the easy way through it, for the easier way. Solving for both of these, this one says when is the sine 0, and this one says when is the cosine squared equal to negative 2. Cade, when is the sine 0?
0.
At 0. Yeah, and at pi. How would you solve cosine squared equals negative 2? What do you do to get cosine by itself? Brandon? Square root. Eris, what happens when you take the square root of negative 2? You can't do it. There aren't imaginary numbers on the unit circle. There are only real numbers on the unit circle. So again, this piece here is undefined. Just like the previous problem, part of it was undefined. So that second piece, you can't take the square root of a negative number. You get an imaginary number. They don't exist on the unit circle. Questions? So these problems are not just quick, simple, straightforward problems. Like they're equations that involve everything we've done in trig, which goes back to November, like the week before Thanksgiving, 15th-ish, I'll say, which is a long time ago, but it just keeps on like building on itself, and you're using all of that stuff, the unit circle stuff, all of that information that we did, kind of all just compiled together in those problems. Questions? Are there others on the other worksheet? Trig is a lot. It's hard. It's a lot of memorizing. It's definitely challenging because of all the memorizing, and like it's so abstract and analytical. And there's no way I can make the concepts, the content any easier. Just try my best to explain it. So if you look, before I give you the rest of the period, I want you to look at, nope, not that one, one more. the last page in your packet, there are 10 questions on there. And the 10 questions are literally just a hodgepodge of problems. So the first worksheet that you had that was reviewed was all like formulas and identities. The second worksheet was all solving equations. And we did that second worksheet in 2 separate pieces. This last chapter 5 review worksheet literally is just a problem from each section, or 2 problems from the 5 sections we've looked at. The first 2 problems here say to verify and simplify. That was the first 2 sections. You had that test 5.1, 5.2, where you're just breaking them down, trying to get it to equal the other side, or trying to simplify it. So that goes back to the very start of the chapter. But if you look at the second 2, because this is what we've like just talked about this week, I just want to make sure you kind of understand how to start the problem. Number 15 says find the exact value for the tangent of 15 degrees. So 15 degrees isn't on the unit circle. We want to use the sum or difference formula in order to help us find the tangent of 15 degrees, which means I need to get 2 angles that add or subtract to be 15 degrees. That's how the sum or difference formula works. And you want them to be on the unit circle because that's the whole goal. So what can we use on the unit circle? 8.
45 minus 30.
Yeah, so you could use 45 minus 30. Because 45 minus 30 makes 15, but now I'm using a difference of 2 angles that we know on the unit circle. So after you get those 2 angles, then you go to the formula for tangent, and you're going to plug them in. Can anybody plug them into the formula for tangent? Virginia?
So tangent 45 plus, wait, no, minus tangent 30.
Okay.
Over 1 plus tangent 45.
Good. So that's the formula, and then you're evaluating. So you're going to plug in a number. The tangent of 45 is this. You're going to plug in another number. The tangent of 30 is this. So you're taking out the tangent, you're taking out the tangent of 45, tangent of 30, replacing them with the values of the unit circle. That answer isn't going to be nice and perfect and friendly like the square root of 2 over 2. So it's going to be a little weird because it's not an exact value that you've got memorized quickly from the unit circle. I'm going to stop with that because you can kind of simplify it a little further. But I also want to start you with number 4 as well. So number 4, similar, find the exact value of the cosine of 120, use the double angle formula. Now 120 is actually on the unit circle, so you might already have that one memorized. But just to get you to see how the formula works, we're using the cosine of a double angle. That's the cosine of a double angle. But our goal is to use an angle that when you double it, it makes 120 degrees. Well, what angle doubled is 120 degrees, Brandon? 60 degrees. So using the cosine of a double angle, which could be cosine x minus sine squared x, that x is 60 degrees. So you're taking the cosine squared of 60 degrees minus the sine squared of 60 degrees. And then again, you're evaluating. So right now, I have the formulas for you. You need to now evaluate the formula. That's how the 2 formulas work. So you get the angles. Once you figure out the angles, that's your x. So 60 is my x. 45 is x, 30 is y. Or u and b, or a and b, whichever variables you want to use. And then you plug that into the formula. Then you're evaluating based off the unit circle. So you've got the rest of the period. Please ask questions. On Monday, you have your Chapter 5 test. On Tuesday, the partner test and the half-sheet word problem is due. One of the 2 word problems, it doesn't matter to me which one you do, just do one of those 2. The Monday test, you gotta have that sheet identities formulas memorized. Questions? Please ask if you have them. I'll be around to help.